I think if you it's like essentially what you're
Some of us are not smart. All right, so time's almost up, so you should be, I should have submitted it. You haven't already. You want to wrap it up?
Oh, yeah.
That's a all right. So let's go ahead and go through these. Okay. The tricky part about number one was the simplifying. I bet you guys were able to like take the antiderivative and all of that. Okay, it's just the multiple choice. Okay. So you guys agree we just separate the variables, right? First step's pretty easy. Did I do that right? Yeah. We integrate. Okay, remembering that this is y to the -2. So we add 1, divide by the new power. So that side is -1/y. The antiderivative of x is x squared over 2, and then there's the plus c. We all right to there? Okay. Now you can do either of the next two steps first, either solve for y first or solve for c. Typically, unless there's an ln of y, I'm going to solve for c. So this time I'm going to choose to solve for c, but those two steps are interchangeable. So they're telling us x is 2 and y is 1. So that's what I'll plug in to find that value of c. So I'd have -1 on the left, and 2 squared is 4. 4 divided by 2 is 2. So I get to here, so the constant is -3. Still with me? Still in agreement? Okay. So the tricky part, I think, comes on the next part. We've got -1/y equals x squared over 2 minus 3. I need to get y by itself, but since y is in the denominator, I'd love to flip that fraction, which I can do if I can make the other side be a fraction. So right now that 3 is over 1. If I can write this side as one fraction, then I can just flip the whole fraction. So I'm going to choose to multiply the 3 top and bottom by 2. So I have -1/y equals x squared over 2, and then this would be 6/2. Because if I, again, can write that side as one fraction, then I can flip this side and flip this side. So that's all I'm going to do. So I want to flip the fraction. So this side is -y. This side is 2/x squared minus 6. And then I can move the negative over. So y equals a -2/x squared minus 6. This answer is not quite there, but which of the listed answers is equivalent to that? D, they just took the negative and distributed it through the denominator instead of the numerator. Okay, so if you have a negative on top, you can put it through the denominator, so that matches D. Okay, so again, you can see how they take something that we're really good at, make the last little bit tricky. So you all want to, practice the simplifying. Okay, I heard a lot of good conversations, good things about this. What happened here? What rule did you do? L'Hopital's. You plug in 0, you get 0/0. So the derivative of sine is cosine. Derivative of the denominator, you take the limit of this, you get 1/1. So answer is A. Okay. All right, today we have, we're gonna go through your questions on 7.4. Have any of you guys taken time to look at your final, the calculator portion, half of your final? Okay, so I'll wait till you guys look at that. Go ahead and look at that tonight. Tomorrow we'll take questions. Let's go to your homework. So yesterday you had the 7.3D assignment. You had this assignment. Let me take a quick look at it. Oh, let's see. Yeah, and 7.4 is review stuff. Yep. Yep. Okay, so it looks like 11. Is that our very first one? Okay. Okay. Okay, so on A, B, C, D, those are just looking at the graph, right? I do think it's worth mentioning E, this set of problems. So, hold on, I'm gonna take this question. Okay, on E, so doing this one, when you're asked to find velocity and our given information is acceleration, how do we go from acceleration to velocity? Good, integral or antiderivative. So we're going to integrate this, and to integrate we need to know the limits. I need to integrate from what number to what number. What two numbers should I choose for E?
0 and 3.
0 and 3. We know 0, we're trying to find 3. So I'll integrate from 0 to 3. This would give me velocity at the upper bound. So this is velocity at 3 minus velocity at 0. This is like a classic fundamental theorem of calculus question. Okay. How are you going to evaluate the integral of acceleration from 0 to 3? Area. They gave us a graph, so we go, okay, under the acceleration from 0 to 3, that triangle has a base of 3, a height of 5, so 15 cut in half. So there's the integral. The velocity at 3 is what we're looking for. They told us the velocity at 0 was 2, so we can just add the 2 over. So the velocity at 3 is, what is that? 19 halves?
It's 9.5.
Yeah, yeah. When you do F, G, and H, it's the exact same process, right? You're just having a different limit. So you're just switching the limit. Okay, on I, when it says at what time in the interval from 0 to 12 is the object moving the fastest? Moving the fastest, what are we analyzing? What are we trying to find? Speed? Okay, what about speed versus velocity? I guess speed, you're right, so we need it to be positive. And they're asking us to fastest, I'm thinking this is the max. So when I read I think to myself, well, they're really just asking us to find the maximum speed during that time. Now, speed is the integral, or speed is the absolute value of velocity. We just want to take away direction. We get velocity by finding the area under the curve. So when would we have the most area under the curve? At what time t would the area under the curve be the largest? 10. See, if we keep adding the area as we go, once we get to 10, it would be all of this area. After 10, we'd start to subtract it, so the maximum would be at t equals 10. When is it moving the slowest? Moving the slowest would be a minimum velocity, so or minimum speed. Again, if we think that velocity is the area under here, the area under would be the smallest at time 0. Because we're going to continue to add area, but even once we start to subtract, it's still going to be positive because I'm only the area below isn't as big as the area above, so it's still more positive than negative. So I would say that it has it's moving the slowest at 0. When is the object slowing down? So when is speed decreasing? Do you guys remember our rule for speed increasing and decreasing?
They're the same sign acceleration.
Good. It has to do with velocity and acceleration. So to be decreasing, we need velocity and acceleration to have different signs. So from 0 to 10, acceleration is positive. Is velocity, well, actually, if we just read the question, it tells us the acceleration graph is an object moving along a straight line. Oh, I guess it didn't say always moving forward. But velocity is always positive because velocity is the area under the curve, and the area under the curve is positive until 10. And like I said, even after 10, it's still positive because we're subtracting, but not enough to make it go negative. So velocity is always positive. Acceleration is positive until 10. So they have the same sign until 10. After 10 seconds, acceleration is negative, but velocity is still positive. So from 10 to 12 seconds is when speed would be decreasing. Okay, so from when t is between 10 and 12, and that's because acceleration is negative in that interval, but velocity is still positive. The total area under the curve is still positive in that interval. All right, then the other question was 13. Okay, so this one asks us to find the x values for which the function is not differentiable and then give a reason why it's not differentiable. This is a good review back to continuity, beginning of the year stuff. What do you notice about that function? Can we do anything? We can take an x out, right? You guys agree we can just take an x out? So really we could reduce it to this function, or we could remove an x, right? So when you factor something out like that, that's a removable discontinuity. So that's a removable discontinuity, which means it's going to be a whole. A removable discontinuity is a whole. The x value that we removed, the number that we would have plugged in would have been 0. So we have a removable discontinuity at x equals 0, because that's the value that made the denominator 0 that we removed. Okay, what other value of x can the function not equal? What other number can we not let x equal? -1. So it also has a discontinuity at x equals -1, but what type of discontinuity is that? A vertical asymptote. So this one is a vertical asymptote, and it's a vertical asymptote because we can't remove it. Sometimes they call it an infinite discontinuity. You go to infinity. Okay, then 15. 15 gives us a piecewise function. Oh wait, that I didn't even answer the question. It's asking us about differentiability. I talked about continuity, which we have to consider continuity because it has to be continuous to be differentiable. But I'm not done with this. Yeah, so if it's not continuous, so at these two values, I've shown that it's not continuous at x equals 0 and x equals 1, x equals -1. We didn't have to go into as much detail as the type of discontinuity, but if it's not continuous, I can conclude that it's also not differentiable at those values. Has to be continuous in order to be differentiable. It's going to be differentiable everywhere else. We don't have any sharp turns or anything like that. I guess we can find the derivative to kind of prove this. So I'll go through this. So let's find p prime. Sorry, x at 2 might be okay. Let's see what happens. So that might end up being okay. It's okay if the derivative equals 0. It just can't be undefined. So to find p prime, I'm going to have to do quotient rule. So I'd have bottom times the derivative of the top. I'm thinking of the top as x squared minus 2x to make the derivative easier. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. You guys make sure I don't mess up here. So I'm going to simplify. I've got 2x squared minus 2x plus 2x. They cancel. Minus x squared and a plus 2x. So again, you guys double check, but I got to here. Would you agree with me? Now, I don't have to check anything because if this is the derivative, it's undefined. This is undefined when x equals -1. But I already knew that. I already said that it wasn't, where did it go? I already said it wasn't differentiable there. So I don't really have to add anything else. It's not differentiable though because the derivative doesn't exist at that point. But it doesn't because there was a vertical asymptote. So we don't have any other points to list. The piecewise function is kind of interesting. In a way, a little bit easier. I still would look for continuity first because it has to be continuous in order to be differentiable. How do we check to see if the piecewise function is continuous? Good. Yep, we're going to plug it in and see if they equal the same thing. So I'll plug 1 into the left side, and I'll plug 1 into the right side, and see if they equal each other. I get 3 equals, is that going to be the same? Yep, those are both 3. So they do equal each other. So it is continuous. So it's worth checking differentiability. If that was no, I could say it's not continuous, it's not differentiable, it'd be done. So now we have to check differentiability. Differentiability is almost the exact same process. I'm going to find h prime. I'm just going to take the derivative of each piece. What's the derivative of the first piece? 2. What's the derivative of the second piece? Let's see. X plus 1. Now, I don't know if I can put the equal to bar. So I know this one had an equal to bar, but that does not guarantee that this one will. I have to check differentiability. So I'm going to do the same thing I did with continuity. I'm just going to see if these two equal each other. So I would plug 1 in, but there's nowhere to plug in 1. So that side stays 2. Then I'd plug 1 into this side. 1 plus 1 is 2. So it is differentiable, both sides. So that means the slope as we approach from the left is 2, and the slope as we approach from the right is 2. So this one is differentiable everywhere. Which, if I wanted to, I could come back up and now I can put that equal to bar there. You could have put the equal to bar on the first one or on the second one. It doesn't matter because they both equal the same thing, but the derivative is defined at 1. Okay, and then 21. 21 is an integral, so we still have a lot of integration practice. I see this as our most common method of integration.
Teachers, pardon the interruption. There is a black Subaru license plate Z395Z that is blocking a dumpster. If it is not moved in 5 minutes, it's going to be towed away. Can you please excuse the students and have them park their car someplace else? Thank you.
Okay, what's our most common method of integration? U sub. Good. So what should I let u equal? Sine. Good. If we choose sine of y, okay guys, derivative of sine is cosine. So it works out pretty nice. We can just rewrite this as 1 over u cubed du. Then just make sure you rewrite that as the integral of u to the -3 and do power rule. So power rule, you add 1 and you divide by the new power. So we'd have a -1 over 2u squared and then just plug the u back in. So a -1 over 2 sine squared of y plus c. Okay, so we'll have more integration stuff on this test. And then 24. A little less obvious. My initial thought when I see this, I'm like, oh, it's exactly like the last one. It's just another u sub. If I do another u sub like the last, what would your thought be on what we could let u equal? Secant. So that would be my first thought. I'd see this and I go, okay, the 1 to the power. Let's try secant of x. But what's the derivative of secant? It's secant times tangent. So we're going to have to just do a little bit of like rearranging to make this work. I have to have one of the secants. I have 5 of them. I have secant to the 5th. I have to have one of them be the derivative of the inside. So I'm gonna rewrite this as secant to the fourth of x. I'm gonna take one of those secants and put it next to the tangent of x. Right, those are still equivalent to each other. But now I do have a du. So this is what's gonna be required to get that du. And this will be u to the fourth. So it's going to be the integral of u to the fourth du. Okay. Antiderivative is easy enough. We add one, we divide by the new power, plug secant back in, so it's secant to the fifth of x over 5, or you could say 1/5 plus c. So sometimes you have to get a little creative or like rewrite it to make it work. Okay, and then the last one I think is 27. Total distance traveled. Okay, so to find the total distance traveled, we have a formula. It's just a lot easier if we had a calculator. That's why I want us to try to do this one without a calculator. Total distance would be calculating like how far it traveled in one direction plus how far it traveled in the other direction. So we can't do displacement because displacement would be like 5 minus 2 if you moved 5 units to the right and then 2 units to the left, whereas total distance would have been 7. So we don't want to subtract them. So what matters is which direction we're moving. If I had a calculator, I could say total distance is equal to the integral of the absolute value of velocity. I'm still going to take this approach. It's just if I had a calculator, I could type that in. We can't deal with absolute values by hand unless we actually break it up or analyze the graph. So I'm going to have to analyze this graph. If I want to integrate velocity, I guess I'm going to not use the graph because I don't know what that graph looks like unless I put in a whole bunch of effort. But what matters is when did it change from being positive to negative? Isn't this a calculator question actually? I think this is calculator.
On the key, they got a decimal.
Yeah, okay, because as I look at this, we can't set that equal to 0, so we can't do this one by hand. So yeah, just do this on your calculator. Otherwise, you'd have to sketch the curve, but you'd have to do that without a calculator. We can't do integrate the part above and then the part below. So you just type that in and you get your answer. So I would just put this in as y1 and then do that integral of the absolute value of y1. Okay. But that wasn't the question you guys asked. You guys asked for 27. Okay. 27, of course. Okay, they give us f prime, f double prime. Okay. Okay, domain. What value can x not be? We would look at the original. Is there any value of x that would make that denominator be 0? Nope. So domain is x can be all real. There are no restrictions. Okay, asymptotes. Asymptotes, vertical or horizontal. A vertical asymptote occurs when the denominator equals 0, but we just said the denominator never equals 0, so vertical asymptotes, there are none. A horizontal asymptote we would find by taking the limit as x goes to infinity of the function. So what would we get if we took the limit as x goes to infinity of this function? 0. So therefore, there's a horizontal asymptote at y equals 0. Okay, so we've done domain, we've done asymptotes, intercepts. An x-intercept is found by letting y equal 0. Y is the function, but if we set a fraction equal to 0, what's the shortcut? Yeah, just the top equal to 0. So that means when we plug in, when we get 0, we get 0 out. Well, 0, 0, that's an x and a y intercept. It crossed both the x-axis and the y-axis. So I found the only intercept. Relative extrema. Okay, so all of that was A. Relative extrema, it's asking for a max or a min. How do we find max or mins? F prime. Good. Fortunately, they gave us F prime, so we don't have to find it. We would look for critical numbers. A critical number occurs when the first derivative is 0 or undefined. The first derivative is this function. When is a fraction equal to 0? when the top equals 0. Well, the numerator equals 0 when 1 equals x squared. So when x is plus or minus 1. So that means those are potential max or min. The derivative is undefined when the denominator equals 0. When does that denominator equal 0 for what values of x? Never, for the same reason that the domain didn't. You can't square something, so that never happens. So our only critical numbers are -1 and +1. Then you do your f prime sign line. So our f prime sign line, we list our critical numbers. F prime was this equation right here. And I'm seeing where it's positive or negative. One thing stands out to me to make it be a little easier is this denominator is always positive. Why is that denominator always positive? Squared. So all I have to worry about is the top. Now, if it's going to take on the sign at the top, I'm just going to consider the graph. That graph is an upside down parabola. So it's going to match the signs of that graph. So it's below the x-axis, then above the x-axis, then below the x-axis. What's our conclusion at -1 then? Min, max, or neither? Min. How about at 1? Max. Okay, so we have found the extrema. They want the extrema point, unfortunately. That means we have to plug it in to find the y coordinate. Has somebody done that by chance? Plugging in those values into the original function. I'll let you do it later. Okay, point of inflection. How do we find a point of inflection? Second derivative. So once again, fortunately, they gave us the second derivative. A point of inflection occurs when the second derivative changes signs. So it's almost the exact same process we went through with the first derivative. I'd say, okay, well, when is the second derivative 0 or undefined? Because it might change signs at those values. I don't know until I actually check, but these are like the possibilities. It will equal 0 when the numerator equals 0. And the numerator will equal 0 at 0 and when x squared minus 3 equals 0, which I could add the 3 over and take the square root. So I get plus or minus √3. Okay, it's undefined, never. It's never undefined for the same reason that the other two weren't. It's x squared in the denominator, so it's always positive. So the possible points of inflection are here and here. In order to be a point of inflection, I need to confirm that the second derivative changes signs. I can do this pretty quickly without even doing anything else. What is the degree? Kind of the same thing as the last one. The bottom is always positive. So I'm really only concerned with the sign of the numerator. I know that it always changes because that's a cubic function. And it has 3 distinct zeros, meaning it has to cross each time. It would only not change signs if the graph bounced, if I had a 0 with even multiplicity. But it's a cubic function, so I know it's starting low. I know it's starting low and ending high. So I know the sign had to go negative, positive, negative, positive. The order that it changes doesn't really matter. It's just that it did change signs. So we have a point of inflection when x equals plus or minus √3 and at 0. You have to take all of that information. I'm going to make you do part D and sketch the graph. But once you have all that information, you can sketch the graph. Okay. I do have. Okay. I have a free response problem. Trying to decide. Yeah, I think let's spend 10 minutes doing this quickly, and then you guys can just work on your review. So 7.4. Your book assignment is just your review. So your assignment is this. It really isn't too bad because there's quite a few that are just like the multiple choice. Here is a free response I want us to look at because it's very similar to a free response you're going to see on your test. So I want you to take 10 minutes on this first.
Dude, there's this dude. I work in Willow Creek.
All right. You know what? This is
Like, I don't care if you call him. He's a solid 10. Thanks. This is me off. But like, I don't care if like you guys do. Like the fact that I don't comes in, it's just a rich pass.
Okay, so with this free response question, on part A, it's slightly different than how yesterday's free response question started. Yesterday, you were asked to sketch the slope field. Here you are provided with the slope field, and they're asking you to sketch the particular solution. Okay, so again, just has to follow the flow. So A shouldn't take you too long. It does ask you then on part B, a tangent line, and then the differential equation. Okay, so I'm going to give you 10 minutes as your group. At 11:21, we're going to go through this. Okay.
Well, I started at 0, 1.
Oh, that's actually
This one's
Maybe something like that. Okay, dude, did you apply for work? I mean, no, it's just something you can compare at graduation. But like, there's way less topics. Like on my sister did way more times. Yeah, like the course, like there's one. So like there's like what you can do as many as you qualify. No, like you have to have a 30 or better on the site portion of the ACT test, and like a certain amount of credits in the science department.
I didn't get 30 on. I didn't get 30 on science. So I didn't get
Ms. Brown?
And then 34 on reading, but I didn't qualify. I got like a 90. Really? That's all right.
Ms. Brown?
That's what's. I just think it matters. Yeah. Yeah. What's stronger? No. I like the snow. Yeah. It is surgically removed.
No, well, that's your slope because it says dydx. So I did f of x equals 3 minus y cosine x because we have a point, that's the slope, right? I don't know because it's kind of
You have this.
Well, I don't know because dydx. You know, we've used you can approximate 0.2 doesn't make sense. Point 0.01 and our slope is up there. I wasn't satisfied with myself, but then I took it. No. Like I had two really nice ones. I know.
I do all the time.
So that was on my last one that I took. But on the first one I took, it was a 29. My overall score was 7. Because I didn't study for it. But so for super score, you got like a 30. You know, I just go to the application.
Does it really matter?
Yeah. But that would have been so cool. Like, you don't get it. You know, like, why would I pay that much to go out for undergrad? Not worth it.
Yeah, I'd say
Okay, guys, take like 3 more minutes and then I want to talk about it.
Oh, yeah.
Yeah, I actually got a significant amount.
I would do dude like
It's not bad. Yeah, Larson.
yeah.
Larson's good.
It's like well, you can work so well. Like I would wait, 7-0. And then
Really
have no idea.
B?
Yeah.
Would you direct the base of the 10th minor?
the point of the slope.
You have a point?
Yeah, 0, 1.
How did, what's the slope?
Is it dy dx? So that's.
So you just plug it in.
And you need to solve this differentiate approximate.
After you, it says use your equation, so after you have your test.
So then you need to plug in first that. Well, how do you do that? No, simplify.
So just replace x on right point 2. You're done.
You have cosine.
Multiplied by 0.2 plus 1. No, can't use calculation. Where does it go? Like that anymore. You're right.
And yeah, the rubric is on the back. You can check it kind of as you go.
I only had 2 periods.
You did.
Half credit to do
Just the
Yes, because you have -1.
Wow.
Yeah, you plugged in line, so plug in X as well. I would just.
Oh, so then that's our slope.
Okay.
This is if you did,
Yeah.
then we would see that x is 2 times x plus 0, which is just x. Plus the y,
They said, did they say quadrant?
Whoever thinking this power is long.
Okay, I'm gonna go through this quickly. Number one, when they're looking to grade it, they're just saying if it's the basic shape. So mine is definitely not great, but if you're following the shape, then you're gonna get that. That's just a 1-point question. Number two asks you a couple of things. So you have to recognize that B is a 2-part question. The first thing it says is to write a tangent line, you need a point and a slope. So you've got the point, then you evaluate the derivative at that point. What did that come out to be? 2. So your tangent line is 2x minus 0 plus 1. No, you don't have to write the minus 0 part, but you have your tangent line, so that's the first answer. Then they want you to use it to approximate the function at point 2. You should be kind of aware of your notation. So I would say the function at 0.2 is approximately this exact thing. And just instead of writing x, I'm going to write 0.2. And I will not simplify. I saw a lot of you guys simplify, and maybe because you looked at the back, but I wouldn't. I would just leave that as my answer. You only waste time by simplifying and risk making an arithmetic mistake. And if you make an arithmetic mistake, you get it wrong. So if you had this correct on your paper, in fact, I'll even leave the minus 0. I'll leave everything. So I'll just say it's that. But then you simplified and you said, I don't know, maybe you simplified wrong and said 1.2. If you box this answer, you don't get any credit. You wouldn't get that point. So I wouldn't even waste my time simplifying. This is it. Then on the separation of variables, so on part C, you separate the variables. So you divide this over. The most common mistake I see is finding the antiderivative on the left. When we integrate this, I'm betting most of you recognize that that's natural log of the absolute value. But there's a negative in front. Why does there have to be a negative in front? Basically a use of. I didn't necessarily go through all of the steps, but I'm letting you be the denominator. What is the derivative of the denominator? -1. So because the denominator has a derivative other than 1, you have to put a -1 on the inside, meaning you take a -1 out. So that's why there's that negative there. I would say that's the most common mistake I see on this question. Okay, what was the antiderivative of cosine? Good. And then you have your plus c. I would just get rid of the negative right now before I try to, and then get y by itself. So I'm just going to multiply over the negative, making that a negative sign. A minus c, but minus c is the same thing as a plus c. The c would just be the opposite value, so it doesn't really matter. So I move the negative over. I'm going to get rid of the ln by doing e to each side. Remember, if you have e to a sum, that's e to the first thing times e to the second thing, which is just another constant. So I have 3 minus y equals a constant e to the negative sine x. My goal is to get the y by itself. So what should I do next to try to get that y by itself? Yeah, exactly. So if I subtract 3, divide by a negative, I get y is, I'm going to say a negative, yeah, a negative c, but you really don't need that negative because it's going to go away. And then a plus 3. What matters is your final answer. So now you use your point. Okay, guys, your point was, what was it? 0, 1. So you're plugging in 1 for y, 0 for x. Sine at 0 is 0. E to the 0 is 1. So that's how we get to here, minus the 4. So negative c equals -3. So c is 3. But what matters, you don't get the credit unless you write your final answer. Y equals -3. I don't know. Thank you. I did it in my head and got ahead of myself. Okay, so let's subtract 3. So we'd actually be a -2. So c is 2. So a -2 e to the negative sine x plus 3. Look at the rubric for a second. Okay, pay attention to these point values. I'm going to grade your test in the same way. So you definitely will have one of these separation of variables. worth a whole bunch of points, like out of 9 points, 6 out of 9, that's a large percentage. Okay, so you separate the variables, antiderivatives, the points are always awarded in the same way. Constant of integration means you remember to write your plus C, used initial condition, so you plugged in, the 0 and the 2 appropriately, and then you solve for y. That last point is often the hardest point to get. Okay, don't worry about any of like the domain. I guess it didn't really state it, but there's no credit awarded there. Okay, so you can just keep this to study if you don't turn it in. Now you guys can just work on your review. So again, your review assignment, it's your 7-4. You guys have, I did skip some of these. There were some problems in here we skipped. So we're gonna do 1 through 23 and 26 and 27. This assignment will be due on Friday, so you don't have a new assignment tomorrow. Tomorrow is just a question day and one more of these free response practice questions for our test. All right, you guys work.
So last trimester. Study.
Can I change my test time on Friday?
Yeah.
We have teachers at 11:30, so I see 10.
Walker, so the free response is 45. I'm getting you 40. 40 minutes. Denise, 40
Yeah.
minutes. I think it can be done in 30, but it'll be. So what time do you want it to start out?
10, please.
10 o'clock?
Yeah,
Okay.
Oh, yeah, same. We all have things.
And you
Same
want
for
the same
me,
time?
10 o'clock.
10 o'clock?
And then we can take the multiple choice whenever.
Anytime, yep.
I'm kind of confused on like how the plan to speed increase and decrease.
Okay, so our general rule is speed will be increasing anytime acceleration and velocity have the same sign.
That's
So like both positive. The reason for this is if we had a velocity graph, let's just make one up. I gave you a velocity graph. I don't like yellow paper. I was thinking about this earlier too. I hate yellow notes.
My dad always.
The yellow kind?
Yeah.
I don't know this color. Okay, so here's velocity. So let's say this is the velocity graph. Speed is the absolute value of velocity. So I can create an absolute value of this graph with the flags from that, and that tail got flipped up, right? So I could say on the speed graph, speed is increasing on this interval here and on this interval here. And on this interval, velocity was positive. So in that interval, velocity was positive. But acceleration, the slope was also positive. It was above and increasing, so no surprise. Over here, though, this piece got flipped up. Well, on this piece, from there to there, velocity was negative. It was below the x-axis, and it was acceleration was negative. But again, because we're flipping it, then it becomes positive.
Oh, so that's how you find where velocity, or that's where I was confused on. How do I know where velocity is?
And that one I think is a little bit trickier on this, and it has to do with the fact kind of what we went through here.
Right.
To get velocity from acceleration, we're doing an antiderivative.
Yeah.
And an antiderivative from a graph is the area. So the velocity is going to be, and because the initial velocity is 2, the velocity at 1 would be 2 plus the area. The velocity at 10 would be the initial 2 plus the area.
Right.
And because that area is all positive, I know that velocity is positive. After 10 seconds, we would start to subtract the area below, but I'm subtracting it by comparison a lot smaller. I know it stays positive.
Use all of it.
Exactly. If it was one
I
like
just thought it
this-
was speed was -2, or velocity would be -2.
Yeah, so it would just be, it would be the
So it's not at the
accumulation.
exact time.
Right, it's not, it has to be, because how we found, like we actually found velocity at 12.
Right.
So velocity at 12, when we found velocity at 12, exactly, and the reason why it was positive is because of this area minus just that little piece. So,
Okay.
uh-huh.
Well, and then
Yeah,
I don't know how to find like.
the x to the 1/3. So either you know what the graph looks like.
Well, I don't get like why it'd be a tangent there.
So, yeah, and if, so let's say we don't know what the
We're not a-
cubic function is, I would take the derivative. So it is continuous, because if I'm looking at this, like, that's the cube root, I can take the cube root of positive. So continuity is fine. there's no issues. Differentiability, I'm gonna take the derivative. So if I take the derivative, the derivative of that would be here. I'm gonna rewrite that so I can analyze it a little bit better. So that's the Q